Here's a GRE arithmetic question. Let's take a look. Which of the following integers has an even number of factors? All right, let's start very, very basically. What is a factor? Well, a factor is a number that can be divided into the number that we're looking at. So for example, let's just take the number 6, right? What's an example of a factor of 6? 2, or 3, or 1, or 6. All of those are factors of 6. Now it's asking us which one of these has an even number of factors, and that means that all the wrong answers must have an odd number of factors. I'm starting to hint at the end here, but I won't give it all away quite yet. What I could do in this case, and it's a little bit of work, is go through each one of these and write out all the factors. It's not as bad as you think. So for instance, if we take 49 and we want to be methodical, let's start with the smallest factor of 49, which is 1, right? 49 and 1 are both factors, and they match together. 1 times 49 is 49. Okay, well, what's the next one up? Not 2, not 3. You can use your calculator to check. 4, no. 5, no. 6, no. 7. Okay, 7 times itself, but that's it, right? So 49 has 3 factors, which are 1, 7, and 49, meaning that it's not even. And again, I could go through this whole list and do that for each one of these, but this is where pattern recognition can be very, very useful. In the words of Sesame Street, which one of these is not like the other? There's one number in here that is in some way different from the other 4. Or I could reframe that and say 4 of these numbers share something in common. Did you notice that 49, 64, 144, and 169 are all perfect squares, right? 49 is 7 squared, 64 is 8 squared, 144 is 12 squared, and 169 is 13 squared. Well, what does that have to do with anything? Well, check this out. You saw when we did this with 49 that we got an odd number of factors. And that's because every time we write out the factor of a perfect square, we're missing one, right? Or one number, the square root of it, is multiplied by itself. So we end up with an odd number of factors, right? And again, you can see this, for instance, with 64. There are going to be a lot more factors of 64, but 1 in 64, right? 2 in 32. What is it? 4 in 16. 6, no. 7, no. 8 and itself, right? It's an odd number of factors. 1, 2, 3, 4, 5, 6, 7. If a number has an even number of numbers, that means it's not a perfect square. Because, for instance, 75, and I'll just take this all the way out here because we've gone this far. Why not, right? 1 in 75, 2 no, 3 and 25, 5 and 15, 6 no, 7 no, 8 no, 9 no, 10 no, and then 11, 12, 13, 14 no. Use your calculator to double check. We have an even number of integers here, or I should say an even number of factors. So that's a little, I don't know, cheat code for the test. If they ask you about whether there are an even number of factors or odd number of factors, you should be looking for perfect squares.